In section 4.5 and 4.6, we are going to attempt to find zeros of polynomials. 4.5 is concerned with real zeros of a polynomial, and then 4.6 is going to extend that to complex zeros. The first thing that we need to talk a little bit about is called the division algorithm for polynomials. And the way this works is if we start with a polynomial, f of x, we can write it as q of x times g of x plus r of x. Or if we wanted to divide both sides by g of x, we can write it as we have on the left here, f of x divided by g of x is equal to q of x plus r of x over g of x. That is, what we're doing is we're taking our polynomial f of x, dividing it by something, that's the quotient, q of x, and the divisor, g of x, and the remainder, r of x. All of that, we're not really going to have to worry about the details of that. What we do need to remember is that we can go back and forth between a polynomial here and a quotient over here. And the reason this is important is to help us factor, and on our way to factoring we look at the remainder theorem. The remainder theorem says if the g of x part, that is this part, if the g of x part is a linear x minus c, then if we try to evaluate the function at c, we're left with the remainder part. So what does that look like practically? So here's our f of x, and here's the question, what is f of 3? So we could do what we did before and substitute 3 in everywhere that we see x and do our order of operations and simplify it and work it out, but we would like to use the remainder theorem to do this. Okay, so in terms of the remainder theorem, if f of 3, what is that, f of 3? So the c that we're interested in is 3. So we write g of x, that linear term, as x minus 3, right here. Then, since we started off with our function f of x equals, we would like to rewrite it in terms of the this division here. So take f of x and divide it by g of x to end up with this division algorithm thing. So taking our f of x, x cubed minus 4x squared minus 5, and dividing it by g of x, x minus 3, what we should end up with is the whole number part plus the remainder part. And if we're using the notation from above, this part, the whole number part's the q of x, the remainder part is just going to be a number, r. We've done this previously when we looked for the end behavior and looking for end behavior of rational functions, looking at the q of x. Now we're kind of going to switch it around and we're going to look more at the remainder part, the r. We can use long division to do this, but it would be a little bit faster and more to the point if we use synthetic division. The way synthetic division works is we look at the denominator, x minus 3, ask ourselves, if x minus 3 equals 0, then x equals 3. So in our box, we're going to put 3. And the way this works is 1, -4, 0, and 5 are the coefficients of f of x, and and we're just keeping track of the coefficients of f of x instead of having to do the whole long division thing. This makes it a little bit shorter. Note here that we have a missing term. There aren't any x terms here, so we have 0 x terms right here. So the way this works is we are going to move from top to bottom. The 1 comes straight down, and then we take 3 times 1 to give us 3. Then we want to add negative 4 plus 3. Negative 4 plus 3 is negative 1. Then we'll do 3 times negative 1 is negative 3. 0 minus 3 is negative 3. 3 times negative 3 is 9. And then negative 5 minus 9 is negative 14. And this gives us our remainder, r of x. So what we can do is we can write f of x, which was equal to x cubed minus 4x squared minus 5. Instead of it writing it x cubed minus 4x squared minus 5, we can write it in this form where we have our x minus c factored out from this other part, and then plus the remainder. Okay, that's one way of writing it. The other way of writing it is f of x divided by x minus c equals that stuff that we just found. Okay, great. So who cares about all that? We don't really care about all that. We wanted to know what is f of 3. So f of 3, if we were to substitute 3 minus 3 times, some stuff over here, nobody cares about what this is because 3 minus 3 gives us 0 minus the remainder of 14, so f of 3 gives us negative 14.